Okay, we're going to start section 10.4 now. 10.4 is all about graphing quadratic equations. There's a definition here. The graphs of quadratic equations are not like the graphs of linear equations or V-shaped graphs like absolute value equations. The graphs of quadratic equations are shaped like an arch, which is called a parabola. Okay, now the most basic quadratic equation is y equal x squared. Okay, that's the most basic parabola that we would ever work with. That graph is shown below. I've also included a table of numbers providing how we get this graph here. So like if x is negative 2 squared is 4. Okay, so here's negative 2, 4 on the graph. If x is negative 1 squared is 1, so here's negative 1, 1 on the graph. If x is 0 squared is 0, here's 0, 0 on the graph. If x is 1 squared is 1, so here's 1, 1 on the graph. And if x is 2 squared is 4, so here's 2, 4 on the graph. Okay, and of course I could plot, lots of points if I wanted to, but so you can see the shape of a parabola. It is not a V. Okay, so when you draw a parabola, make sure that there's a nice smooth turn through the vertex. Okay. Now, there's lots of different ways that you can draw a parabola. We're going to focus on the steps that are listed here below. It says to graph a quadratic equation, y equal ax squared plus bx plus c. Step 1. You're going to check if the parabola opens up or down. Now we're going to know that immediately by just knowing the a value. Okay, if a is a positive number, the graph opens up. If a is a negative number, the graph opens down. Step 2 is we're going to find the vertex. Okay, the vertex we're going to call point V, and point V is going to have coordinates x, y. To get x, we need to compute negative b over 2a. Once we have that number, whatever it is for x, we're then going to plug that number in to get our y value. The vertex is either the highest or the lowest point of the parabola, depending on if it's opening up or down. Step 3, you're going to find all the intercepts. So all the points where the parabola is going to cross or touch the coordinate axes. And then step 4 is where you're going to sketch a graph. Now, on occasion, you may need to plot another point or two, plot some more points if it's necessary, and then sketch the graph. Okay. There's a definition here. The axis of symmetry is the vertical line x equal negative b over 2a. That vertical line is going to extend upward through the vertex. And a parabola is always symmetric about this vertical line. So in other words, like on this graph, x equals 0 would be the axis of symmetry. Okay, and that means that if I spin the parabola about that vertical line, I would get the same picture. So one of the features of a parabola is that it's going to look the same on both sides. Of course, if you're drawing this by hand, you'd want to make sure that you have something that looks the same on both sides. Okay, I'll see students sometimes, maybe they're quick with the drawing or something and they slap up something and they have something that, kind of flares way out here, it just doesn't look the same on both sides. Okay, so like any other graph, you'd want to be neat with what you're doing there. All right, let's take a look at some problems now. Problem 14. Graph the equation y equals x squared minus 2x minus 3 by determining the vertex, the intercepts, and whether the graph opens up or down. So we'll just show the work on the side here. The parabola, and by the way, I should know right away that I'm going to be drawing a parabola, okay, since I've got a quadratic equation given. This parabola is going to open up since the a value is 1. And because the parabola is opening up, the vertex is going to be the lowest point on the graph. I want to calculate the x value first by letting x be negative b over 2a. A is 1, we just said that. B is negative 2. So the opposite of b would be 2. Divided by 2a, a is 1. 2 over 2 is 1. Okay, so knowing that x is 1 means that I could get the y value then by plugging that number into the equation. So that's what I've done here. 1 minus 2 is negative 1, minus 3 is negative 4. V would be located then at the point 1, negative 4, and that again would be the lowest point on the graph. Okay, that's the vertex. Step 3 is to find the intercepts. So I want to find the x and y intercepts here. To find an x-intercept, I need to let y be 0 and solve for x. And so that's what I've done. I've let y be 0 and solve for x. And I've got a quadratic equation. Remember, the first thing always when solving a quadratic equation is to think factoring. This one will factor nicely for us as x plus 1 times x minus 3. Set the two factors equal to 0, and you'll have x equal negative 1 or x equal 3 as the solutions to that equation. The y-intercepts are found by letting x be 0. So if x is 0, I'll just have y equal negative 3 then. All right, so I'm going to have 3 points then that I would list that are the intercepts. Negative 1, 0, 3, 0, and then 0, negative 3. At this point, I think I'm ready to sketch the graph now. Okay, so I know I'm drawing a parabola. This parabola opens up. The vertex is located at 1, negative 4. That's right there. And then I also know 3 additional points on the graph. Negative 1, 0, 3, 0, and 0, negative 3 would be the intercepts. And using these 4 points then, I can draw a parabola. Okay. Now it's not asking us to do this, but you'll see that I've got a vertical line here, a dotted line. X equal 1 would be the axis of symmetry. And a couple of problems they'll ask you the axis of symmetry. Okay, they're not doing that here, but in other words, that vertical line would be creating a parabola that is symmetric on both sides. Okay, so if I spin the graph about that vertical line, I get the same picture there. Here's another one. Okay, problem 15. We're going to graph y equal negative 3x squared plus 6x plus 1 by finding the vertex intercepts and whether the graph opens up or down. Okay, so this parabola would open down. Since a is negative 3, that's a negative number. It's going to open down. So this time when I find the vertex, I'll be finding the highest point on the graph. I got to get x first. X is negative b over 2a. A is negative 3. B is 6. Okay, so I want the opposite of b, that's negative 6, divided by 2a. 2 times negative 3 would also be negative 6. Negative 6 over negative 6 is 1. And so knowing that x is 1 means that I can plug that in here to get my y value. Negative 3 plus 6 is 3, plus 1 is 4, so y is 4. Okay, negative 1, 4 would be the vertex then, and yeah, that's going to be the highest point on the graph. So then we want to find our intercepts. To get the x-intercepts, we'll let y be 0 and solve for x. This equation is not going to factor nicely for us, so we'll use the quadratic formula. And remember, the quadratic formula should always be a plan B option if you don't see right away if the equation factors there. So we'll want the opposite of b, that's negative 6, plus or minus the square root of b squared. 6 squared is 36, minus 4 times a is negative 3, times c is 1, and this is all over negative 6. 36 plus 12 is 48. The square root of 48 breaks down as it'd be 4 root 3 if you were to break that down, but I don't think that really matters because I'm going to have to know where to position these points on the graph. So I'd say at this point, why don't we go to the calculator and type in these two numbers. So I'll go ahead and do that here. We've got, negative 6 plus the square root of, 48, 0.0, so I get a decimal, okay, and then divided by negative 6 is negative 0.15. Okay, so that's what I got here. And then negative 6, let's see, negative 6 minus the square root of 48.0 divided by negative 6 is 2.15 then. Okay, and to get the y-intercepts, I need to let x be 0. When I plug in 0, I get 1. So I'll go ahead and graph this now. I know I'm drawing a parabola. It's opening down. The vertex is at 1, 4, and I'll plot the intercepts now. So 2.150, that's be about right here. Negative 0.150, that'd be about right here. And then 0, 1, that's right here. Okay, now notice that these 3 points are all below the vertex. That should make total sense to us because the vertex, I've mentioned, is the highest point on the parabola. Okay, so any point that I plot has to be below that point there, of course. Okay, using these 4 points, I'll draw on the parabola. Okay, a nice smooth turn through the vertex. Make it look symmetric on both sides of x equal 1. Okay. Problem 16 is the last one I had in this section. So same deal, graph the parabola. Okay, y equal 3x squared minus 3x plus 2. This parabola would open up. Since a is 3, that's a positive number, it opens up. The vertex, okay, x is, we want the opposite to be over 2a, so that's going to be 3 divided by 2a, 2 times 3 would be 6. 3 over 6 is 1/2. So then to get the y-coordinate, I would need to plug 1/2 into the equation there for x. I've done that. 1/2 squared is 1/4, times 3 is 3/4. I'm subtracting 3/2 and then adding 2. Well, I'll want to get my common denominator there. So 3/2, that's the same as 6 over 4. 2, that's the same as 8 over 4. 3 over 4 minus 6 over 4 is negative 3 over 4, plus 8 over 4, that'd be 5 over 4. Or 5/4 would be the y value here. Okay, so 1/2, 5/4, that's going to be the vertex. That's the lowest point on the parabola. And now we want to get the intercepts. Okay, so to get the x-intercepts, I need to let y be 0. This one is not going to factor nicely no matter what we do with guessing and checking. And so this will be another quadratic formula situation. I want the opposite of b, which is 3 plus or minus the square root of b squared. Negative 3 squared is 9. Minus 4 times a is 3. Times c is 2. And this is all over 2a. 2 times 3 is 6 in the denominator. 9 minus 24 is negative 15. Negative 15 is the discriminant. So I would get complex solutions. Now, you have to think, like, for what we're doing here where we sketch a graph, we're not doing anything with I or imaginary numbers, okay? So there would be no real solutions to this equation. As far as the x-intercepts go, then there would be none of those to list. Okay, so I'll just write none. To get the y-intercepts, I need to let x be 0, and when I plug 0 into the equation there, I get 2 in return. Okay, so 0, 2 would be the only intercept then on this graph, the y, where it intersects the y-axis there. All right, now, so I'll go ahead and draw this. I'm drawing a parabola, it opens up. The vertex is at 1/2, 5/4, that's about right here. We don't have any x-intercepts. I think that makes sense, right? Because this point is the lowest point on the parabola. Of course, it's not possible to have any points below that on the x-axis, right, if this point is the lowest point on the graph. And so that's, probably something I could have observed ahead of time before I did the problem, is that there's going to be no x-intercepts. And then here's 0, 2 then. Okay, so I would probably want to plot like at least another point or two just to have a more accurate thing. Now, remember, one of the features with a parabola is that it's going to look the same on either side of the vertex, or the axis of symmetry. Okay, so the axis of symmetry for this problem would be x equal 1/2. And now this point, 0, 2, is a half unit away from the vertex. If I go a half unit to the right of the vertex, I should have a point at exactly the same height. Okay, and in other words, 1, 2 should be on the graph. Well, let me check that. If x is 1, 3 minus 3 is 0, plus 2 is 2. Okay, so 1, 2, yeah, that'd be on the graph. I've got 3 points now to work with, so I can draw on this parabola using these 3 points. Of course, I can plot additional points. You know, the more points you plot, the better. You shouldn't need 5,000 points, though. Okay, you know, just get 3 or 4 works great in order to draw the graph. So. All right, that's all I had for this section. The homework is on page 818. Be sure to look at the odd-numbered problems listed there.